Hey folks, welcome back to another adventure. Today we are actually going to be putting parts together. So it's crankshaft day today. And we're back. Okay, today we're going to be putting the connecting rods onto the crankshaft. This is the O360 A4K build. Most important thing here is we've got our crankshaft set up. Real important is we've got a nice crankshaft stand here. This is actually a Goodson, pretty nice product. It's got some Delrin or plastic V blocks. You can make this out of wood if you want. The most important thing is whatever you're going to hold your crankshaft in or on, make sure that it's made out of something softer than the crankshaft. Same thing with your aluminum cases. We've got some stuff here. They're sitting on rubber pads. So most importantly, whatever you take any of these machine parts, always put them on something softer than they are. So this is a real nice rig. It's adjustable. We can use it for dimensioning our crankshaft. We can also use it for the camshaft. We can even do some run out and that kind of stuff. So it's really kind of a nice, pretty nice piece of gear. It's it's from Goodson. They do make a lot of automotive stuff. Probably see it in you can go to Goodson Direct, or maybe even some other checks might even have it. But real nice piece of gear. So we like it. Anyway, today what we're going to do is we're going to be putting the crankshaft together, the connecting rods onto the crankshaft. Real quick here. Most importantly is per the manual. We got the manual, we got the service bulletins. There's some service instructions out there. Some old service instruction, 1307B, which has been rolled into our current manual, so it's all good. But bottom line is, we're going to be putting these connecting rods on per the manual. It's the numbers of the connecting rods go down. So we've got the engine oriented this way. Easy way for me is what we're going to do is the way I Lycoming. Now for you Continental folks, pay attention. On Lycoming, the engine, the crank throws are numbered, or the cylinders are numbered from front to back, whereas on Continental it's from back to front. So if you're building different engines, you just got to remember that. Also, if you're trying to tie magnetos on a Continental doing the Lycoming way, that's not going to work either. So you just got to remember where you are, what kind of engine you're working on. So on this one here, what I like to do is there's number one, and then I'm going to have number one and number three over here, and then this will make 2 and 4. So I know that when I start putting my connecting rods in, I know which one goes where. So now we've got our connecting rods figured out. We've got number 4, set that here. And these are all numbered, the caps, all that. Make sure you keep the caps together. All this stuff has been dimensioned. Everything's been measured. All that stuff. So we're in great shape. There we go. Most importantly, all new hardware for the connecting rod bolts. So these are going to be, this is all brand new hardware for the connecting rod bolts. And then when we have the packaging, I always like to hang on to all the packaging just in case something comes up years from now. We'll have the packaging in case there's a problem or all that. So we're going to have 2 nuts on each one. Now, in a Lycoming, they don't use cotter pins like Continental does. That's just a different way of doing it. They have enough torque on there so that it is bound, it is tight. There's not going to be any cyclical kind of loads that would loosen that up. So that's the way Lycoming does it. A little bit different from Continental. So we'll get this stuff out of here. We'll get our plastic stuff off our bolts. These are the latest, greatest bolts. And again, what we're going to do with the bolts here is we're going to put them in get our fluid in there, our oil. So get everything set up that way. Boom. So let's put on, well, because it's handy on this end here. Well, actually, I'll just move around here. We'll put on number 1 and all that. So boom, boom. And these have all been cleaned off and all ready to go. Whoops. So I've cleaned the throws here. I've cleaned these. Clean the throws, clean the base of the connecting rods. And what we're going to do here is we're going to butter these up with some engine oil per the overhaul manual. Okay. I'm going to double check our numbers. Okay, this is number 1. This is number 1 throw right here. And this is number 1 here. So number 1 down and number 1 down. You'll see actually on the at the Lycoming factory they use a brush. I prefer not to use a brush just in case you might have a bristle that might let go. I just don't like that. So then we have number one. Going to come in here and number one down. Boom. And then the bolts will go in. And we'll actually probably get a rubber mallet just to make sure that they're where they need to be. Okay. And the nuts go on. Nuts go on these. The nuts go on. It's a tapered nut, and you'll have the tapered end down toward the base of the connecting rod. So that's that. The other thing you'll find out too is we'll get into this a little bit when we torque it, that we're going to have to use a special socket that's been ground a bit. Okay, so that's one down. Boom. So next one is 1, 2, 3. This is a 3-main engine. Boom. 1, 2, 3. If you mess with V8 engines, car engines, it'll be a 5-main. These are 3-main engines. So here's number 2 throw, number 3 throw. So we'll bring that around. Boom. Get it ready to go. Cool beans. Okay, number 3, number down. Okay, number 3, number down, and number 3, number down. Boom. Boom, boom. And when you put these bolts in, you want to make sure that they are even as far as rotationally, so that they sit home and do what they need to do. Okay. So that's 2. I'm going to come around here, get the other one. Okay. Repeat as necessary. We'll see after. Let me get these others on, and we'll be back in just a little bit. Just follow me along. Okay, we're on our last one for initial tighten. This is the number 1 up front, and we're just making sure everything's good. We're using a plastic mallet to just set the connecting rod bolts. Now, if you're an automotive guy, you're probably thinking, well, these bolts look like they're in backwards, because automotive stuff normally have studs in your connecting rod, large end, and then the cap will be held in with some nuts. Well, these aren't. This isn't your father's Oldsmobile. So, most importantly is this is the way they go. You'll also see that these have kind of a chamfered edge on them. That's for crankcase clearance and all that. So, real important to put these in correctly. If you're in the automotive business, it's kind of interesting. These bolts are PMA parts. They're superior PMA parts, but they're made by ARP. Kind of cool. They make a lot of high performance automotive engine stuff. So if you've ever been wondering about your hot rod, your car, you're building an engine up, ARP makes good stuff. So most importantly is I want to make sure everything's down. This is my number on this one. This is number 1 down. Number 2 is down. Number 3 numbers are down. That's another thing. You hear the clank. These rods on this thing, this is all aluminum, so it's all softer than the crankshaft or camshaft, so it's kind of nice. So you're not going to tear anything up if you clank into it. And number 4 down. So everything's going the right way, so everything's cool that way. Now what we're going to do is we're going to go to final torque. As I mentioned, you can't really see it. I'll get a picture of it here in a little bit. But as I mentioned, the socket is that we're using is actually ground. I don't know if you can see it here, but if we use just a stock 6-point socket, it only goes down about half the height of the bolt. So what you need to do is take one of your favorite sockets, and you're actually going to have to put it on a lathe or a bench belt sander and smooth it up so you can get it down low. This is 9/16. So again, a little bit of a special tooling deal, not that big a deal here. Okay. What I'm going to do here is I'm going to do an initial torque. Okay, I'm not using a click type torque wrench. You're correct. I'm using a beam type. The reason I use a beam type or a meter type, I prefer a beam type. I've been using it for years. Years ago, the factory used to use the beam type. But what this allows you to do is keep about a 5-second, 10-second torque on this. So what I'm going to do is I'm going to bring these all up to about 20, and then we will we'll tighten to our final torque after that. Now we can also take this out of the stand. I may take this out of the stand to do the torque just so it lays flatter. There's 20. There's my number 1. Number 2. And anytime you use a beam torque wrench, always remember to, we call it float the handle, but always react on the pivot pin, have the handle centered. Nice thing about these is these never go out of adjustment unless it gets in a fire or something, but if that's the case, throw it out. Of course, depending on where you are, you always want to still double check calibration on it, make sure it is correct. There we go. Get it tightened up here a little bit. Come here, girl. Cool. Like I said, depending on how we go here, we may end up moving to taking this off the rack. Starts jumping around me. This is kind of the first time I've ever torqued up on a rack, so bear with me. First time I ever had a nice one. So if you're going to do this for real deal, then definitely get some good tools. Okay, so this is all at initial torque. We're going to go to our SSP 1776 document. That was that special document I told you here a while ago, and that one will be telling us to torque to, for code S, we're going to go 480 inch-pounds, which is, last time I checked, man, it's hot in here with all these lights on. Not that hot without everything else on. I got the fan on, windows open, but it's hot. 480 inch-pounds, so 480 divided by 12, I think, is 40 foot-pounds. Do your math out there. So now we'll do 40 foot-pounds. $40. Now what we're going to do here, like I said, we're going to take this off of our rack and let it lay on the, let it just lay on the counter so it's a little more stable. There we go. Oops. Boom, boom. Okay, you've started seeing me kind of fight it a little bit, and that's okay. I've got the crankshaft on the table. It's like, well, why don't you put it in the crankshaft stand? The reason I don't put it in the crankshaft stand is I'm going to have to take it out to put it in the crankcase. So I don't really feel the need to go do that. Now, some folks will assemble the whole engine on the crankcase stand. Some will assemble the whole engine on the bench. What I typically do is I'll build up the crankshaft, and then one more to go. And then I'll set the cases horizontal, just like the factory does. And then I'll build the center section on the, there we go, all torqued up. I'll build up the center section on the table here So I'll have the two crankcases, crankshaft in it. We'll put the gear on it once it's in the engine. A little easier to hang on to. And then we'll put the two cases together. Then we'll have a setup where it's pretty stable. Then you'll see we'll put it on the the crank stand or engine stand. And then the reason we do that is it's a lot easier to put the cylinders on. Now, can you put the cylinders on the workbench? Yes, you can. What we need there is we need a special, I shouldn't say special, but you need a support for the bottom of the engine. So you want to have the sump on and all this other stuff. When you're doing that, you might as well build all that stuff up. It's easier to build that up on an engine stand, the crankshaft stand. So that's just one way of doing it, whatever you want to do. Most importantly is, as you see, we put fresh paper on this before we started. This was all clean. Fresh paper. We've got our stand here. We're going to put it back up on that. This will all be lubricated and probably put WD-40 on it. And now this has all been torqued to spec. All new parts. All the dimensioning has been done. If you are putting an engine together and your mechanic doesn't know how to operate a micrometer, doesn't know how to use feeler gauges, ball gauges, T gauges, you need to move on. So there's all special precision tools. If you want to go and use, if your guy goes and uses plastic gauge or something like that out of the auto parts store, well then it's just a tractor engine. I hope it's experimental, but go by the book. They tell you how to measure everything. Next time what we'll do is we'll give a little primer on how to use a micrometer down at 10,000ths of an inch and some of the other tools we're using. So that's it for this one real quick. Just putting the crankshaft together. Most importantly is protect your crankshaft. Make sure that everything underneath it is softer than it is. This is $5,000 right here, just the crankshaft on its own. So we want to take care of it. Most importantly is we're going to lubricate it and then we clean it. Now before we put this in the crank case, this will all be cleaned. All these bores will be cleaned off and all that. So be real diligent about that. So that's about it from this end. Like, share, subscribe, notify, and all that. And next time we're going to be putting this in the crank case. So in between then and now, I may see some of you folks up at Oshkosh, but it's hotter than heck right now. But we'll catch you kids later. Hanger Rats out.